I'm now going to be showing you ecosystem particles, emitters, and global particle options. What we need first is a surface to emit particles from. Particles are emitted from the surface normals of an object that has an ecosystem particle emitter assigned to it. So I'm just adding a sphere to the scene. And what I also want to do is raise this up above the ground, because we're also going to be taking a look at collisions. We also want to open up just the timeline, have that visible. F11 on the keyboard is the default for that. You can also go up to Display, and under the Timeline option, Show Timeline, which you can see the keyboard shortcut. You also have the ability to undock the timeline if you want to be able to move it somewhere else, maybe off screen, to another monitor, or just somewhere else within the interface. It will not dock anywhere else except the bottom. I'm just going to redock that. So with the sphere selected, I'm going to go up to the Aspect tab and edit the material. And I'm also going to rename this so it's not confused with the material that's also applied to the ground, because they're both going to have the same name and start with kind of the default surface. So I'm just going to rename this emitter normal. And then what we want to do is add an ecosystem. So ecosystem/particles. And if we go to the general tab, what we can do is add in an object particle. And at this point, we can basically select anything to react as a particle, any object or vegetation. What I'm going to do is go to Load an Object, and from the Particles section that comes with View, I'm just going to load in the sphere. And then we can also set, and we want to turn on particle motion. And this is going to give us some new options. The first new option you'll notice is the velocity. There's a max and a minimum value, or sort of a randomized value. So we can have our velocity at 0.5 meters per second, basically, and then a variable of 0.5. So it can have a variation of particle speeds. Just with the current setup, if I go and scrub the timeline, we're just going to see the surface just flowing from the object, all of those little spheres. So the force that's currently being exerted on this is gravity, which is set up by default. And if we go into the material surface and under the particle motion, we can click Edit to open the global particle configuration. The animation range is set up to automatic right now. And we'll take a look at the other settings, domain length and simulation rate, in a minute. But if we look over in the forces section, we can see that gravity is checked. We have negative 9.81 meters for the force of gravity. So the negative making it move on the negative z-axis if you have z as the up and down axis. So a little bit of drag force on it. We can set up a turbulence, which is kind of a jittering of the particles. And depending on how high you have that rate, I'm going to go ahead and set the turbulence to 10 just to show you what kind of happens when you have that turned on. And actually, it's a little difficult to see, and we may need to bake the particles to see that turbulence. Or possibly need a higher value. Actually, we'll go ahead and just take a look at that a little bit, maybe change that value. The ventilator influence is the influence of ventilators within the scene, so you can use ventilators to influence particles just as you would influence the old ecosystem vegetation, or from older versions of Vue, you would have a ventilator just to influence the ecosystem, blowing leaves around and such. Those can now be used to influence the particle as well. And I have a scene that is included with the training to show that. We can take a look at that in a little bit. So right now, I'm just going to go ahead and close this out. And if you notice, what we have are the particles going through the ground plane because we don't have a collision for it. Collisions, you can use any object as a collision, basically. You select the object from the Object tab, or the Object menu up at the top, Enable Collisions. Once it's enabled, the particles, once they reach the collision object, will basically stop, and then in this case they start to spread out. You'll also notice that the particles are intersecting with each other. And what I'm going to do for now is go ahead and set the preview to smooth shaded so we can see the full object. And spheres preview very quickly on View, and View can support a lot of sphere objects, much higher than if you were to bake the sphere as polygons. So the preview of them is very quick. If we go to the particle motion, we can also turn on, we have collisions turned on by default, so that way it is colliding with anything that has that collision option turned on. We can also turn on the collision with other particles, and then we can set a tolerance. So now as the spheres start bouncing into each other, you'll see it spread out a lot more. And the tolerance allows a bit of intersection, because we can see a lot of the particles will start to, or the spheres will intersect each other. And we can change the tolerance to make it react a little better. If we go ahead and set the tolerance to 0.9, we should see what looks like more intersections. And go back, change that to 0.1. And as we start to lower this value, it's going to take more time to calculate because we're now calculating the surface more accurately. So the lower the tolerance, the less intersections you're going to get, and something that's a little more accurate, although it does take longer to process and calculate that. I'm just going to go ahead and turn that off. Now for the individual particles, you'll notice that since we enabled the particle motion, we no longer have a scale setting for the particle. And that's because all the particles have their own settings or a different panel that can be used. And if we go down to the bottom, we can see there's an Edit Specimen button. So what we can do is select the instance of whatever you're using as a particle, and then we can edit the specimen. And then this is our particle characteristics for this sphere. So in this panel we have the scale, and then the variability of the scale. And this moves both negative and positive. So adding +1 to the scale, increasing the size and also decreasing the size. We can also determine the mass and the weight. There's also an option on the bottom to always face the camera, which is useful for billboards and using sprites. Within the Evolution tab, there are a lot of different options for having the opacity change throughout the lifetime of the particle. So you could have them fade out over time. You can set life size variation, so they do scale over time. You can also base it on altitude or change the color over time. Periodic emissions, we can add additional particles so that during these particle emissions from the particle itself, another particle can be emitted, or another object, whatever you have loaded in. The ability to die on collision, in other words, remove the particle once it collides with another object or another particle, if that option is turned on. And then upon that collision, so if it collides with something, we could also have it create another particle. These options I'll go more in depth into later. I just kind of want to go through some of the overall features right now, and then we'll look at some of these more specifics within different scenes. We can also set up the duration of the particle itself, so it only lasts a certain amount of seconds, and also have a variability. And then also the ability to emit based on the depth of the particle. So same way as the collision. So if it was to collide with something and create a particle, in this case it would die, in other words, be removed, and then you could also have it create another particle. And there's a scene I have set up for this to demonstrate these settings, and we'll take a look at that a little later in a different section. So what I want to show you right now is some of the things we can do with velocity for modifying the particles. And first what I want to do is just go into the gravity and the particle configuration and just remove the gravity so that the only force we have is the velocity itself. And what we're going to see is the particles kind of expanding from the object because there's no forces for the particle. It's just using the velocity and then that variable velocity. We can also control the velocity with a function. There's a lot of benefits to this, and there can also be some drawbacks as well. So this function is set up to use basically the surface direction of the normal using a vector and then tying that into the root emissions. So what we're doing is defining the direction. I'm going to add a constant node, so just right click, add a constant, and I'm going to add a constant vector. And what we can do with this is define the XYZ direction and the intensity of the velocity on that axis. So leaving it at 0, there should be no motion really at all, except it looks like the drag force being applied. We're going to go back to the function, and let's go ahead and set 50 on the z. And what we'll see is all the particles flying upward on the z-axis. Now, one thing you'll notice is that we don't have the variability setting when we control it with a function. The variability does disappear, and that variability does need to be controlled with the function itself, which means you'll have to create a little more of a complex function in order to create variability. You can mix it with noise nodes, and essentially you would have to break down the vector with math nodes using the composer and decomposer functions, which would allow you to break apart the vector and recombine it. And that way you could use a numbered base function, so you could use noise and tie it into, say, the z along with adding that 50, and then that could create variability. So as we change the directions and intensity on the velocity, now we can see it moving to the negative x, because I added a negative value. So it's all based on direction. And I'm just going to go ahead and disconnect this. You can right-click on that drive with a function button to disconnect it and go back to the default. So now let's take a look at controlling the amount of particles that are generated from the surface. Right now we have quite a few particles, and these are defined The amount of particles is defined by two settings, one being the emission flow, which is under density, where we can decrease this value and lower it, the amount of particles a bit. If you're going to be using the emission flow for this, what I've noticed is you have to use a fairly low percentage, say 0.1, in order to really see an impact. But there's another setting that does control the overall creation, and that is within the particle motion. If we edit, and that is the simulation rate, which is based on a Hertz value. So if we change this value to, say, 90 Hertz, and I'm going to go back to the density and bring it back to the default, so we can just take a look at the way the Hertz influences this, and we'll go back on and turn on the gravity as well. So with the Hertz rate, we can also get a more accurate calculation of particles. Lower simulation rate. Right now I set it to about 5 Hertz. There aren't as many calculations per second. So we could bring this down to, say, 0.2. And what we're seeing is that the particles just kind of drop to the ground very quickly. Not really much going on there. So less particles are being created, and the calculation per second is reduced. So if you notice a lot of particles kind of flying off in directions, or it looks unstable, it just doesn't look, not really doing, if a couple of particles or some of the sections aren't really doing what the rest of the particles are doing, you can increase the Hertz in order to create a more accurate calculation.